Hey guys, it's Mrs. Conway. So today what I want to do is go over the Unit 2 study guide. So if you were in class already, if you have me this week, you will get a hard copy of this. But I've also posted it on Teams as a PDF, and you can access it through OneNote. So you could choose to complete it any of those ways. You could print it out and fill it out and take a picture and submit it on Teams, or you can turn it in person if you're going to be in person. Either way, what I want you to do right now is watch this video to check and make sure you did all of the questions correctly. Make sure you're explaining your reasoning in words. Because this is pretty much what your test is going to be like. So let's look at this first problem set. For each question, tell whether it is always, sometimes, or never true. Explain your reasoning in words. And this goes with ASSE 3, which is choose and produce an equivalent form of an expression. So we're basically saying, does one side of the equation, is it the same as the other side? So when we're looking at it here, question part A for question 1. And this over 4 is on the test. I'll grade you out of 4 points on this question. 3 minus x squared equals 6. So one way to do this would just be to start thinking about it. Is there any way you can do 3 minus x squared and get 6? It might help if we get rid of this 3. So we've got a positive 3 here, so I'm going to subtract it on both sides just so that I can look at x by itself here. So that gives me 3. So I've got negative x squared equals 3. I'm still having a little trouble because of this negative. It confuses how I would see it, although you might start to see here, anything I square is going to be positive. So then that negative is going to make it negative, but this is a positive 3. You might also remember if you have negative in front of x, you would divide by negative 1 to get rid of it. So now I have x squared equals negative 3. Well, now you can really see that I would have to take the square root of a negative number in order to solve this. And in Bridge to College, we are considering imaginary numbers to not be a part of what we're doing. So this is never true because you can't square root a negative number. And the better way to say that would be because x squared is always positive. Now, remember, you have to actually explain all of these. So the answer is that this is never true. But you do need to explain it. Okay, the second one, we're going to have to do some algebraic manipulations before we can tell if it's ever true. Because it's just too hard right now. Now you could, there's a couple different ways to do it. You could, with this division here, you could divide both of these by 3. But that'll give me a fraction, and I would rather get rid of the fractions, and everything is a denominator of 3, so I'm going to actually multiply both sides of the equation by 3 in order to get rid of all my fractions. So when I do that, I have 3 times 1/3, which is 1y, plus 3 times 5 is 15, equals y plus 10 divided by 3 times 3. The 3's cancel, so I just have y plus 10. Okay, so I have 1y plus 15 equals y plus 10. Now you might start to see here, if I'm adding, if y is the same number, right, I have a 1y here and a y here, which is the same thing. Add 15 to one and 10 to the other, that's never going to be the same. But you might go further and subtract y on both sides and see that the y's cancel out, so you're left with 15 equals 10, or you might have got 0 equals negative 5. Either way, this will never work, because 15 does not equal 10. Okay, and you have enough algebraic proof if you've done it this way that you're good. Now you might have decided to go from here, so you would have to explain, well, something plus 15 plus that same number plus 10 is never going to be the same. Make sure you explain it. Each of these should have a sentence at least. Okay, now this one. I've got 4x plus 8 equals 4 times x plus 2. So we probably want to distribute this so that we can see what's going on. 4x plus 8 equals 4x plus 8. Okay, it's the same thing on both sides. So this is always true because these are the same expression. It's just the distributive property. Okay, now this one, I add 2 to both sides. 3x equals 15 divided by 3. X equals 5. Okay, well, I got an answer So 5 works. Remember, to show that sometimes is true, something is sometimes true, you would show one number that works and one number that doesn't. So 5 is a solution, but 0 isn't. So I just plugged 0 in really quick to show that 0 does not work. So that proves that this is sometimes true. Okay, so that's what you should have for the first problem. For A, you should have never, B should be never, C is always, and D is sometimes. And you should get that x equals 5. Okay, so hopefully that one wasn't too bad, although those first 2 are a little tricky. Number 2 is definitely more difficult, and this is actually the same thing as task 12, just different numbers. So if you struggled with task 12, you might look at this to help you with that. So we've got, suppose a friend tells you they paid a total of $258,540 for a house, and you'd like to know the house's list price, so the price before taxes, so that you can compare prices on Zillow. Find the list price P of the house if your friend bought a house in Washington, where the sales tax is 8.6%, Idaho, where it's 5%, and in each state where it's R. Assume R is already a decimal. Okay, so first of all, reminder about decimals. If we're doing 8.6%, that's 0.086. So I just want to remind you, when you're buying something, you have to pay the total price plus the sales tax. And so that's what this $258.40 is. $258.40 is like if I had a receipt, you've got however much the thing cost plus tax, and that's my 258,540 number. So how do we find tax? Well, tax is the 8.6% of 258.40. So, or sorry, of our initial price. We don't know what our initial price is. So we're going to do 0.086 P, which is our tax, plus our price, which is P. And that should add up to 258,540. Okay? And now we have to solve that equation. Now, remember, if there's just P here, that's 1 P. So you do 0.086 plus 1. So that's going to be 1.086 P equals 258,540. And now I'm going to have to divide both sides by 1.086. So P equals 38066.2983, which is 0.30. Remember, this is money, so round to 2 decimal points. So over here we would write $238,066.30. Okay, so that would have been the list price if the sales tax was 8.6%. Now what if the sales tax was 5% because we were in Idaho? Well, that's 0.05. Okay, so now we're going to do the same thing, but instead of 0.86, it's going to be 0.05. So you're going to have 0.05 P plus P equals 258,540. And now that's going to be 1.05 P equals 258,540. And then I have to divide by 1.05. Okay? So now I'm going to do 258,540 divided by 1.05. And remember, this number should be bigger, right? Because sales tax would have been less of the money. So I got, when I did that, 246,228.60 because I got 57, which rounds to 6. No, sorry, brain, that's just 57. 571. Okay, so $246,228.57 if we were in Idaho. So it goes, the house now would have cost more because less of the total is sales tax. So now it's asking us, well, what about if it's just any sales, any state, and it's already, R is already in decimal format. So now we're going to do what we've been doing, right? R is now what we put instead of the tax. So we're going to have RP plus P equals 258,540. Every time I had R, or your sales tax, I'm putting R instead. So in my original equation where it was 0.086p or 0.05p, I'm now putting R instead of that number. Okay, and I don't have to account for it being a decimal because we already did that. Okay, so now we're solving for R. So I need to get R by itself. So I have RP plus P equals 258,540. I need to get R by itself. So right now I'm adding P, so I need to subtract P on both sides. So RP equals 258,540 minus P. And then I have to divide by R. So I have to divide this whole side by R because we don't know what this total is. So sorry, not R. I'm trying to get R by itself. I have to divide this P. So those P's would cancel. R would equal 258,540 minus P over. Now I could divide these separately. If you want to write your answer as 8,540 over P minus 1, you could also do that. Whichever makes more sense to you, I would mark either one correct. So you could have 258,540 minus P over P, or 258,540 over P minus 1. Whichever seems more simplified to you. All right, so that question is a little tricky. So if you want more practice on that one, you could go back and redo task 12. That was in one of your Delta Math assignments. I think it was lesson. Okay, so let's look now at question 3. So now we're looking at inequalities. So this is a word problem that has an inequality that you need to use an inequality to solve. So Jose wants to buy a cell phone that costs $600. He already has $400 put aside. In order to save up more money, this is important, more money, he's going to shovel snow from his neighbor's driveways. He plans to charge $15 for each driveway, and any extra money he uses, he'll buy accessories for his phone. Okay? So first we have to define our variable, which I haven't gone over specifically in class. But that's where we say what letter we're using and what it's going to stand for. So what do we want to know? It says write and solve an inequality that represents the number of driveways Jose should shovel in order to save the minimum amount. So right here, that's telling us our variable. So our variable is whatever letter you want to use, maybe N, maybe D, maybe X. But N is the number of driveways Jose should shovel. When I ask you to define a variable, it needs to be not necessarily a sentence, but definitely like a phrase at least. Okay, an inequality that we're going to write, you can write it however you want. You might say, okay, he's got $400, and then he's adding $15 every time he shovels a driveway, and we need that to be more than $600. Okay, or you might have done it the other way. Maybe you're like, well, he's getting $15 for each driveway, and he already had $400, and that needs to be more than $600. Or maybe you saw it the way that it's written up here. Maybe you say, okay, well, he needs $600, so $600 is the minimum, so it needs to, my amount of money needs to be greater than, so it's $600 is less than, $400 plus $15 per driveway, if you're writing it in the order it appears up here. So any of those inequalities would work. You could also have 600 is less than 15n plus 400. So whichever one makes the most sense to you in the context of the problem. Okay, I personally prefer the first one I wrote, which is why I wrote it first, but I would mark any of these correct. So make sure your answer is one of those. Okay, solution. Now I have to actually solve this. So I'm going to solve the first one, but you should get the same answer no matter which one you solve. 400 plus 15n is greater than 600 minus 400 on both sides of the equal sign. 15n is greater than 200. Divide by 15, divide by 15. N is greater than 13.3. So right here, you would go ahead and put n is greater than 13.3 because that's the answer we got. And then what it's asking down here is graph the solutions on the number line. That's where I put like, I'm going to start this at 0, 4, 6, 8, 10, 12, 14, 16, 18. So if n is greater than 13.3, that means we're going to have an open circle on 13.3, and it's got to be all the numbers bigger than 13.3, okay? As long as you've got 13.3 on there and a number line, I'm happy. But what's a realistic number? Like 13.3, you can't do that. So could he do 13? No, because then he wouldn't have enough. So it's got to be at least 14. And so that would be right here on the graph. Okay? So you don't necessarily have to, so how would that be reflected on the graph? And it's any number to the right, any whole number of 13.3. Now, here's the other thing. It says realistic. At some point this would end, wouldn't it? I don't know what a realistic number of driveways is. It depends on the winter and how strong he is and how long winter lasts. But you know, there is a cap to how many driveways he's actually physically going to be able to do. And then you would have an endpoint over here, right? So just that's kind of what this is getting at, is at some point there's too many. He's not going to be able to do 1,000, well, depends on the winter, but 1,000 driveways would be a lot of driveways for one winter for one person to do. Seems to me winter's 3 months long. Say he did 5 driveways a day, 5 times 30, like 150 driveways seems like about your maximum. Because he's probably got other things to do besides shovel driveways. Okay, so solve the following inequalities, show your work. So these we're just solving. Remember, the inequality symbol is just like the equal sign. Whatever you do to the left, you have to do to the right. Your big difference, if you divide by a negative, you have to flip the sign. Divide by a negative, the sign. So for part A, I'm going to start by distributing because I don't want those parentheses there. They're going to make this harder. So that's going to be negative 4 plus 28x is less than 4x minus 4 plus 4x. Now I'm going to combine like terms. There's nothing on this side to combine, so I'm just going to carry that down. But here I've got 4x and 4x. That's 8x minus 4. Now I'm going to get the variable. I like to get the variable especially for inequalities on the left because it can cause all sorts of issues if you try to get it on the right. So I'm going to subtract 8x on both sides. And some of you might move the other number at the same time here, but I'm not going to, just to make sure I'm being careful. So that is less than negative 4, add 4. Ooh, so I'm going to end up with 20x is less than 0. And so I divide by 20 on both sides. X is just going to be less than 0. Okay, and one of the things that never changes is whether there's a line on this or not. So it just stays less than. Okay, and that's the answer. We don't have to graph that. Okay, so the next one is a fraction again, kind of like the one in the always, sometimes, never true. So I would start by getting rid of that 2 by multiplying both sides of the equation by 2. So those just straight up cancel. So you've got negative 9n minus 35 is greater than or equal to 20. So now I'm going to add 35 to both sides. So negative 9n is greater than or equal to 55. And now I have to divide both sides by negative 9 because I need to get rid of that negative 9. And this is the part where if you divide by a negative, you have to flip the sign. So I divided by negative 9, so that's a greater than, so it becomes less than or equal to. Greater than or equal to turns to less than or equal to. Again, whether or not there's a line on that will never change. And then I'm going to reduce that, and it doesn't really reduce, so it's just negative 55 over 9. And that's it. So that's your Unit 2 practice test study guide. Remember, another good study technique, if you struggled with any of these, after you've worked it out correctly one time, rewrite the question on a separate piece of paper and try to do it again without looking. See if you can remember what to do. So, come to class ready to tell me if you are ready for the test or not. And good luck.